We're going to start work on a haunted house, System 80 MPU board, and the client had indicated that there's the memory test failed. That's not too much of a surprise given that we have an AMI chip here, so that's going to come out for sure. The battery area here, this original NiCad battery that was here, is leaked over this whole reset section, so I'm going to scrape that whole section, and including down here, this 7474 Z2 is a bit corroded. This is one of Robert Doerr's, what do I want to call it, transient voltage blocking devices. And he's got this on the switch matrix returns, and these are the two chips that usually get blasted when stray voltages are shorted to the switch matrix. And Robert says that this thing is working well. It's kind of a neat little piece of engineering. The card edges on this board are not too bad. I think I can bring those back to life. Oh, somebody over here had added solder to the display outputs. I don't like when that is done. I generally leave it, because by the time this has been done and the connector's been on there for a while, the connector relaxes and accepts its fate to have to deal with this thicker card edge connector. So if I take the solder off, then we may develop connection issues on those two connectors. Let's see, other than that, we've got the OEM U2 and U3 and the original 6532s at U4, 5, and 6. So let's get started. Well into the alkaline corrosion abatement process, and you can see I had to take off the 6502 because there's a little bit of corrosion encroaching underneath it, and some of the legs of it were showing corrosion. And getting rid of corrosion is a lot like cancer doctors. When they operate, they'll always take a little more than the cancer. They'll take some of the margin, and then they'll biopsy the margin to see if it's clean. So I do kind of the same thing on a much less serious situation, but it's approximately the same in concept. So I got a little more sanding to do here, and then I'll conformal coat these. Doesn't look like I've lost any traces, which would be surprising and pleasantly surprising. I took out the AMI 5101 and installed a machine pin socket. Machine pin sockets only when I use a machine pin device like this one. This won't be going in there, but I do have a NVRAM 5101 that'll be going in there, and it does have machine pin legs. Here I've added a 3K pull-up resistor to the read-write signal. And we are on the bench with this System 80 MPU from the haunted house, and I have abated all of the alkaline corrosion. You can see that I've sanded to bare copper in this whole area and cleaned up the traces and through holes. I have installed a couple of jumpers. These are all outlined in the pin wiki, 1, 2, 3, 4. And I have installed the equivalent of the Dallas Maxim 1811 reset generator, replaced the 5-volt filter cap on the input. Had a bit of corrosion on Z2 and Z3, so I've replaced those. And when I was testing it earlier, I found out that Z16 was not working correctly, and it was preventing the ones digit from occurring on players 3 and 4. This again is a handy little doodad. It's a voltage irregularity suppressor, I'll say. It shunts or it clamps the voltage on the strobe signals, or is it the strobe, or is it the output? I don't remember. It clamps it on one of them, so that is proven, I guess, per Mr. Robert Doerr, to prevent damage to the switch matrix when stray voltages are touched to the switch wiring. had to replace a whole bunch of 4.7K resistors here, these 0.01 caps here, 3 dip switches, and we are good to go. I've booted it. No, I haven't booted it, so let me boot it. Power on. Now, with the stock ROMs, there's a 5-second delay. I do have power, and you can see we were booted up and we are in attract mode. Let's see if it does exercise all of them. No, there's a few of them that it won't exercise in attract mode. But the displays are up and running, and I had to change some of the dip switches since I did swap out those dip switches because, like I mentioned before, the corrosion had gotten all the way over into here. It's better safe than sorry to swap those things out. So let me get into test with my simulated switch inputs, and I'll skip to test 16, which is the solenoid test. By the way, this driver board came with it, and then 2 up here for the coin lockout, and then it goes into attract mode. And here we can see that all of the LEDs are lighting and extinguishing as they should. So we know that this driver board is good, at least from the lamp circuits. Now let me advance the test to test 17, which is solenoid test. And keeping in mind, this is the installed solenoid test. 5. Let me run that one more time. I missed some of those. And it's only going to do some of the solenoids. 1, 2, 3, 4, and then up to the top, 5, back down to solenoid 9. It skips solenoids 3, 4, and 8, I think. I never can remember that because those are the coin counter solenoids. So I'll come back and get those later. I'll put the GPE Quick Scan 80 on here. So we've got switch test now, going through the diagonal from upper left to lower right, proving all of the switch matrix is operational. I won't press 77, but I will press 67 and 76. That's because 77 on haunted house ROMs, well, at least on Spider-Man ROMs, it causes the MPU to do something funky. So this is display test, and I've got the players jumbled up here. I need to move my player 2 and 3 displays. Now here's where I had a failure before, is on the top set of displays, player 1 and 3, the 1's digit were not being displayed, and that is because of the 7404 at Z16 was crocked. So we'll let this go for a little while. I've got a mixture of displays here. The top 2 and this one on the right are Lizzie 80 displays. These 2 came from Xpin, and I can highly recommend these Xpin displays. They're quite nice. All right, that's enough of that. Let's jump to test 20, which is the memory test, and it should say 99, which it does. So this CPU board is definitely good to go. I'm going to put the Quick Scan 80 on it now, and we'll test all the circuits of the driver board. All right, I have the Quick Scan 80 kind of dangling from the TC1 connector. I really need to make a place for that thing on my test rig here, but let's boot it up, and this is where you'll see something on the Quick Scan 80 display. It comes up 4, 5, 6, 1, and that is testing U4, U5, and U4, U5, U6, and Z5, which is the 5101. So all 4 of those chips are good. Now, if I hold down the credit button, it says it's skipping to test 2, which is lamp test. And the Quick Scan 80 runs through them a little bit slower. I have had a conversation with Ed at Great Plains Electronics, who was the father of the Quick Scan 80, about being able to adjust the speed. So that tests all of the lamp circuitry. Now, the advantage of the Quick Scan 80 now, when I hold down the credit button, It's going to go to test 3, and it's going to test all of the sound circuitry first. So those are the 4 sound signals that come from Z13 on the driver board, and you can see they're progressing in sort of a ones complement countdown there. 5, 4, 2 lower ones is 3. If you're counting with me on binary, you know what this is all about. Let's jump to the next test. All those sound circuits are working. So test 4 is solenoid test. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let me do that one more time. I'm struggling to watch through the camera and live. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so all the solenoids are being driven correctly. Good news, this driver board is good to go. So let me get the other driver board on there and test it. That's the only other thing that I need to do from the box O boards that came with this System 80 MPU. Be right back. And I have the second driver board attached now. And we're going to restart the test. I've watched this. Q10 right now is out. And then Q20 came out now, is out. But the rest of these are all operating correctly. So I have located Q10 and Q20, and I'm going to replace those in just a second. There's a couple of things of note here. When these blue LEDs light, these two appear to go in reverse order. They are in reverse order. Ed actually drives them in the correct order, Q11, Q12. The game software drives them in Q12, Q11 order. So let's skip to solenoid test as I pan back here. Try to remove as much glare as I can. I'm sorry, sound test is the next test. We can see all those signals are working correctly. Now solenoid test. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. All the solenoids are working properly. So let me go repair. This is a MPS U45. These are pricey and hard to find, or at least they used to be. Paulson and I used to joke about whether a driver board was MPS Q45 worthy or not. Take off on the famous Seinfeld episode. And this is an MPS A13. Those are widely available now. So I've replaced Q10 and Q20. They've got silver stripes on them. I'll probably change those to gold. And here we can see the Q10 circuit is fully operational, as is the Q20 circuit. This is in attract mode. I took the Quick Scan 80 off of the CPU board just because it's a lot quicker to view the lamp circuits in attract mode. So that's it. 2 driver boards and a haunted house MPU board all wrapped up. Merry Christmas, everybody. Ho, ho, ho. I hope that everybody enjoys a peaceful and prosperous Christmas and New Year's, and thank you so much to everybody who's supported me over the years and has watched the videos and have made commentary and things to improve, etc. I really appreciate it. The test stopped right now, so I'll have to advance it to 17. Thank you so much.